You have seen that from an ERD, we derive a table and use create table statement to define different columns. We use insert statement to insert data rows into the tables. The main purpose of a database management system is not just to store the data, but also facilitate retrieval of the same. So now, how do we see the data that we have stored in a table? That's when select statements come into picture. A select statement in its simplest form is select star from table name. Here, the select statement is termed as the query, and the output we get from executing this query is called a result set or a results table. Let us take table book for our example here. Select star from book when executed from the command prompt would give out the result set like this. You can also use IBM Data Studio for executing these select statements. For better viewing, we have used the command prompt outputs. Make a note that this is not the exact output for this particular query, since we have truncated the result set for display purpose. Star here refers to all the columns that are there in the table. As you can see, all the data rows for all the columns that are in the table are displayed. We can retrieve data for all the columns by specifying the column names individually in our select statement too. Here is an example of that. The result set is same as our previous example, but we are using the column names here. Relational databases allow retrieving a subset of columns from a table. In this example, we are retrieving data from just two columns, book ID and title from the table book. Select book ID, title from book. Let us see what happens if the order of the columns are interchanged as in this example. Select title, book ID from book. As can be seen in the result set, order of the columns will always match the order that is passed to the select statement. Order as defined in the create table statement is, we are now quite familiar with this query, right? Select book ID, title from book. Let's assume we have a need to restrict the result set. For example, we need to know the title of the book whose book ID is B1. Relational operation helps us in restricting the result set by allowing us to use a clause where. Where always requires a predicate. A predicate is a condition that evaluates to true, false or unknown. So for our need, we shall use the where clause with the predicate book ID is equal to B1. Take a notice of the query that we have used. Select book ID, title from book, where book ID is equal to B1. The result set is restricted to just one row whose condition evaluates to true. We saw an example which used the comparison operator equals to. We have other comparison operators that are supported by the relational database management system. Here is a list of them. Equals to, greater than, lesser than, greater than or equal to, less than or equal to, not equal to. You can try out these different operators yourself to know how they work. Relational databases also allow us to limit the number of rows we want to view, although the result set may have many rows to return. We use fetch first n rows only. This is a clause that restricts the result set. The example select book ID, title from book, fetch first two rows only will restrict the output to only two rows. We can use Boolean operator AND to further restrict the rows by supplying multiple conditions. This AND operator needs two predicates, and rows satisfying both predicates are called qualifying rows. Note that the order of the predicate does not affect the result set. Select book ID, title from book, where book ID like B% and title like getting %. You might have noticed the character % here in this example. We shall revisit this particular wildcard character after few slides.